All right, let's look at problem 1 here, the mathematical induction proof. First, determining which claim is true. I'm hoping that you decided claim 2 was the one that was true. The others are not true. And so you'll get 2 points for indicating somewhere in your work that claim 2 was the one that you were going to prove. That could be just by circling it, or it could be just by clearly showing in your proof that that's the one that you're proving. Okay, so 2 points just for knowing that claim 2 is the true one. And then if you chose the wrong claim, there will be places in your proof where you could get some partial credit, mostly the sentence pieces. But then there will be places in your proof where you wouldn't be able to earn the credit. So let me know if you're confused about kind of where your credit would land. So here's what the proof would look like for claim 2. So first thing would be to establish the basis step. So that would be just showing that the sum of the first partial sum on the term by term side, which would be 5, that could have been calculated by using the formula side, but n equal 1. So 5 times 1 times 1 plus 1 over 2. And then you just leave it to the reader to know that they could simplify that. 1 plus 1 is 2, the 2's cancels, 5 times 1 is 5. And so we usually we don't really show the steps for simplifying that. We just kind of think it out in our heads that it would work. Okay, so 1 point for the basis step. Okay, now moving to the inductive step. Okay, so getting started, you start with your assumption. So we assume that either use the math symbol correctly or use the words there exists some value k from the natural number set such that our claim holds true or is true, either way, for n equal to k. Okay, getting started there, we'd have sum of the first k terms would be 5 plus 10 plus 15 all the way up to 5k, and our claim is that that could have been calculated by just doing 5 times k plus 1 all over 2. Okay. 1 point for this sentence here, and then 1 point for this piece right here. Now a note, I noticed that some people have a tendency to say like for all either k and n or for all n and n here, and you do not want to say that. That is actually contrary, that's circular reasoning. We're just saying that there's one k value. We're not saying that this is true for all k values, because that would be circular reasoning. That is what we're trying to prove. So you would miss a point if you say one of these things next to this line, okay? And some people don't think it's a big deal, but it actually is. It would be evidence that you're still not clicking with the theory, essentially, behind mathematical induction. Okay. Now moving on, so here's your assumption. Now, all we must show is that our claim is also true or also holds true for n equal to k plus 1. Okay, 1 point for that little statement there. And now let's get started on that. So s sub k plus 1, first you write down what it would be on the term by term side. So it would be all the way up to the kth term like you see in the assumption. But then it would have one more term on it. It would have the k plus 1 term on it. And this is not the part we're arguing. What we're arguing is that, so this is kind of like your goal. Our goal is to show that this line, using our assumption, could be written as 5 times the k times quantity k plus 1 times k plus 1 plus 1. So I'm just replacing all the n's with k plus 1. Okay, so this is our goal. Now, comment, a lot of folks have a tendency to write that right here on this line, and that looks very bad logically, and to put it here in your proof. So you need this to be the very last thing that you write for this part of your proof. So it should go off to the side, clearly not connected to this piece. Okay, next, from there, you're going to use your assumption that the first k terms would add up to this expression. So you replace this piece of it with 5k times k plus 1 over 2. But then you need to bring down that last term there. And then when you make that substitution based on your assumption, you need to write by our assumption next to that line. Okay, points. We're going to give you 1 point for this row where you just show s sub k plus 1 term by term. You do not connect it to anything like this. 1 point for that line. And then 2 points for the substitution with this expression in for 5 to 5k. Oops, 2 points I said, sorry, 2 points. And then 1 point for bringing down that k plus 1 term as well. And then 1 point for saying by our assumption. So this is kind of an important step here that we're on with lots of points. Okay, now from here, there are different ways to go about it with just getting it simplified. So the next couple steps do, however, need to look like factoring, essentially. So basically showing that this can be factored and written like this up here. So typically people get common denominator next, and then combination of adding the fractions together and factoring out at the greatest common factor out of the top. 5 and k plus 1 that would be the greatest common factor, and then you have to multiply it by k to get the first piece, and then plus 2 to get the second piece. And then from there, I just need to rewrite k plus 2 as k plus 1 plus 1. There we go. And at that point, I've finished kind of creating that loop that if you can get from the kth step, you can always get to the k plus 1 step. And then with the basis step, you've got the whole thing. So now it's just a matter of the summary. So therefore, the sum of the first n terms defined as 5 plus 10 plus 15 all the way up to 5n could indeed be calculated as 5n times n plus 1 over 2, and that is true for all n that are an element of the natural number set. And we did that by mathematical induction. Either QED or a little box at the end, okay? Let's see, points. 1 point for writing this using all the symbols correctly, exactly as I have it written here. Same order, all that. 1 point, and then 1 point for the by mathematical induction there. There we go, and let's make sure that adds up to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, am I missing one? 12, 13. Hold on a second. I feel like I'm missing something. Oh, I am missing something. Ah, 2 important points. Sorry, guys. 1 point for passing through this at any stage in your work. There it is. And 1 point for this. There we go. Okay, now it should add up to 15. So if you printed the test, you could just circle the 15 if you got it perfect, or just put a number over the 15 to show what you did earn if you ended up with some partial credit there. All right, my friends, hopefully that makes sense. If not, if you're not sure how to score it at this point, just chat with me in Zoom as soon as possible. We'll get it all figured out for you.